Hi, this is a supplementary math lesson for Algebra 1, lesson number 112, the equation of a line through 2 points. And I am going to be referencing this lesson starting on page 402 in your textbooks several times during the lesson. So I'd like to go ahead and get your textbooks open to lesson 112 on page 402. Go ahead and pause the video now if you need to get there and then restart it. Okay, so that first part of the lesson, and yeah, by the way, I've my shave for today. My days of not shaving, I guess, are over. That was one of the benefits of not having to go to school each day. That is one daily task I loathe doing, shaving, but it only can go so far. Back to the lesson. So lesson 112A, they have a, go ahead and read through that lesson. They have a quick discussion there. We have been dealing with the equation of the line, what we call the slope-intercept method. Okay. Now we recognize, if we have that equation of this line here expressed in slope-intercept method, we recognize the coefficient, the number before the x term, represents the slope, and this constant term, the term without the variable, represents the y-intercept. And in algebra, we rearrange things all the time. We can rearrange this exact same equation in this form. I bring the 4x over to the left. In fact, I bring everything over to the left side of the equation, and I list it in terms of x, y, the constant equals 0. Okay? They call this the standard form of the equation of a line, of a linear equation, because any equation to the first order where the variable is to the first power, it's not x squared or x to the third, any equation of two variables to the first power will be a linear equation. Okay, either of these equations, if we put ordered sets into those, they will graph the same exact line. For an ordered set, if I put these ordered sets into this equation in y-intercept method, in the slope-intercept form, it will return the same answers as I do here, because they're the same equation. They're just rearranged differently. Okay, so there's many different ways we can rearrange equations, and mathematicians do that in different ways because depending on the application, we want the information readily available to us through our eyes at a moment's notice. Okay, so in the instance where we're graphing things, we like things in the slope-intercept method because we can immediately identify the slope and the y-intercept to help us graph. Okay, there are other applications in math where the standard form of a linear equation is more interesting to us. Okay, so I just want to point that out, and there's a handful of different common ways in math we can even express linear equations to get the information we need to our eye right away. Okay, just so in graphing we are using the y-intercept, the slope-intercept form, I should say. That other one I just erased is called the general form. We won't use that here through the rest of the year, but that will come into play in Algebra 2 when that day comes. Okay, right now we're going to go to example 112.2 on page 404 in your textbooks. Okay, so we want to determine the equation of a line that goes through these 2 points. This is our next step up in graphing lines and determining equations. So what we do, and by the way, from here on out, if you want to put all your work on your graph paper, and so you don't have to staple your lined notebook paper to your graph paper, just go ahead and put your work on the graph paper as well as your graphing, and that way I don't have two papers stapled together for these assignments. Just do all your other written work right on the graph paper if you would like. Okay, so the step, what we're going to do, we're going to go ahead and plot those 2 points. I have point 4 minus 2, so that's 1, 2, 3, plus 4 in the x, minus 1, 2 in the y, and I have point minus 3, 4. Minus 3 in the x, 1, 2, 3, plus 4 in the y. Puts me up about right here. Okay? I'm going to connect those and draw my line in. Okay? I'm going to determine the equation of the line passing through those points. And I notice right off, my line, when I read from left to right, is proceeding downward. Okay? So I would expect, I'm going to go to my slope-intercept method for the equation of the line. I would expect my slope to be negative. I'm just going to put a little minus sign up there in parentheses just to remind me. I expect that to be negative as it comes up. Okay? Well, what we would normally do if they gave us this line, we would pick 2 points on it and determine the slope. We would pick one where they exactly crossed on our grid lines. Okay? Here they give us the points. We know those points exactly. Okay? The weakness of doing it so far graphically is we have had to guess where those points are. Okay? Now I look at this line right here. Okay? Does it actually cross at 1? Okay, I drew my graph. Now I don't have graph paper, or I don't have a grid system up here. Okay? It kind of looks like it crosses at 1, but it might be just a little bit above 1. Okay? So if I were to select this point as 0, 1, I might be off a little bit. Well, let's see how it works out, because they're telling us we know for sure it goes through those 2 points. Those are the 2 points I've graphed. Those are the 2 points I'm going to use to construct my triangle, okay, to determine, and this was over minus 3, my slope. Okay? So here is my slope. What I'm trying to figure out first is my slope. Okay? And what do I do from left to right? I know start from left and reach right. So what do? I drop 1, 2, 3, 4, 5, 6 units. I'm dropping 6 units. I'm coming over 1, 2, 3, 4, 5, 6, 7 units. I'm coming over 7 units. So what is my slope? My slope is my rise over my run. What is my rise? My rise is actually not rising, it's falling right off. A minus 6 over a run of 7. Okay, that is my slope right now. And I put that mental note up there. It should be negative, and it is. It's minus 6/7. Okay, well, what do? I put that into my equation. M is now minus 6/7. I bring that minus out in front. I don't typically leave it in the numerator. I attach my x, and I have b. Okay, now what do? I need to find my y-intercept. Now I said I can go to my graph and say, well, what is that y-intercept? Okay, what is b right here? Okay, I could graphically select it and say, well, it's 1. Okay, but our days of kind of guessing through graphical means are over. Since they give us 2 points, and we've learned from, way back, I think in elementary, or at least 7th, 8th grade, if we have 2 points, they define a line. Okay, the exact definition of a line. We need 2 points to define a line. They've given us those 2 points. We can determine the exact equation of that line. Well, how do we do that? Well, normally when we would graph a line, we would put in ordered pairs into our line. We would pick values for x and see what y comes out to be. We're going to kind of use that same concept here. We're going to select an ordered pair, and it doesn't matter which one. And your book goes through in example 112.1, okay, using either one. It doesn't matter which either one of these ordered pairs we're going to do. I'm just going to select, I don't know, let me select this bottom one. Okay, I'm going to plug that into my equation. Okay, so what is this? Effectively, this is an x coordinate, and if I plug in minus 3 to my equation, it will return a y coordinate of 4. Okay, I have an x and a y here, that I can plug into. And then what is the only unknown in my equation? B. In other words, if y returns a 4, when x, this is my slope, 6/7, when x is a -3. Now, anytime I put in a negative number into the equation, I like to do it in parentheses. Okay, plus b. What do I have here? I have a number. I'll have a number multiplied by a number. I have an unknown. I have one unknown. I can find what b is. Okay, it's going to be 6 times 3 is -6 times a -3 is 18. And a 7 times a 1 multiplying fraction is a 7th. Okay? And so then I can determine what b is, plus b. Okay? How do I determine that? I have to solve for b isolated on one side. Okay? Since it's already over here on the right side, let's move this 18/7 over to the other side. So 4 minus 18/7 is going to equal b. Okay, well, what do I have here? I have to do some fractional subtraction. Okay, I have to convert the 4 into 7ths. Okay, so what will that be? If I convert 4 into 7ths, it will be 7 times 4 is 28/7 minus 18/7. Okay, that will equal, hopefully I'm not running out of room here, 10/7. Okay, well, what do I do with that? That is what I've solved for b. Okay, I put that in for b here. My equation of the line then becomes y equals -6/7. My slope is the same. Okay, and my b is now plus a positive 10/7. And that is the equation of my line exactly. Okay, that's the answer they come up with at the top of page 405. This is exactly the equation of the line that will pass through those 2 points exactly. And so now we notice, what is the y-intercept? B equaled 10/7. Okay, or what we would say 1 3/7. Okay, what that shows us is the actual place that it crossed is a little bit above 1. It's 3/7 above the 1 coordinate. Now I saw here, it looked like it did cross a little bit above, right there, above 0.1 on my graph. And that bears out here exactly. It crosses exactly at 10/7. Okay, so that's how we could, and now if I would have picked this point up here, okay, so for x I would have put in 4, and for y I would have put in -2. I would have gone through, I would have still had to do some fraction, either addition or subtraction, and you know what, it would come up with the same value. Okay, it would have to. Okay, so to return the same value. Okay, so that is our drill. Okay, we plot the 2 points they give us. We determine our slope triangle from those 2 points. Okay, we determine the slope. We plug in the slope to the equation and leave b unknown. We take one of the points they give us and we plug in one of the values of x and y for that to solve for b. We're going to have some fractional subtraction or addition there to do it. That gives us our equation. So we look back and say, okay, it is a negative slope. It's 6/7. Well, that's pretty close to 1. So is our slope kind of in the middle? Is it that 1 value? Is it in between steep and shallow? And we notice, well, yeah, it's right in the middle. And it says that our y-intercept should be a little bit above 1. Does that bear out on when we drew our line there? Yeah, it looks like it does. So those are some checks that you can make when doing that. Okay, I want to draw your attention quickly to example 112.3. Okay, so they gave a scenario there where the ordered set they gave was 4, 3, and 4 minus 3. Okay, so we put those on our graph. 1, 2, 4, 1, 2, 3, 4, and up 3, 1, 2, 3, over 4, and minus 3. And we connect those, be more like right here. And we connect those dots. And we notice we have a perfectly up and down vertical line. So when we go to determine our slope of that line, okay, the slope, what do we get? The rise of the slope is what? Well, how much does it rise? It rises 1, 2, 3, 4, 5. We could say that it raises 5 units. And how much does it run? What is the run? Okay, well, the x value, the x coordinate here, 4, is the same for both. Okay, what does it run? It doesn't run any. It runs 0. Okay, when we have division by 0, that equals undefined. Okay, the book makes a special note. Okay, a vertical line has an undefined slope. Sometimes mathematicians will say a vertical line has infinite slope, which isn't any more helpful to us in a practical sense because infinity has no end to it. Okay, how do you define infinity? It's just undefinable as division by 0. Okay, where we say a line gets steeper and steeper and steeper as that number gets bigger and bigger and bigger, and the extreme of that is a line that is perfectly straight up and down, perfectly vertical. Okay, it has infinite slope. Okay, it doesn't have a run. It's infinitely steep. Okay, it's undefined, and consequently, if we have a line that is perfectly horizontal, when we determine that slope, okay, we would say, what is the rise of that line? It is 0. What would be the run of that line? Okay, that would be infinite, an infinite run. Okay, now this doesn't give us a mathematical problem like it does with division by 0. 0 divided by any number, even if it's infinity, is going to equal 0. So in the case of a horizontal line, we typically say it has 0 slope. There is no slope. Okay, and as we said, as the slope of a line gets shallower and shallower and shallower, the number gets smaller and smaller and smaller. And if it gets so small that it's 0, it has no slope, it will be perfectly horizontal. So those are some points they brought up in the text there. An infinite line, they're saying it has infinite slope. Sometimes some people say it has undefined slope. Some people will say it has infinite slope. And then the textbook agrees with others that a horizontal line has 0 slope. Okay, a diagonal line, a sloped line, will have a value in between 0 and infinity. So I hope that helps with your homework set. Shoot an email or a text message with any questions. Bye for now.